This video deals with the chain rule, which is the most important rule with derivation that deals with composite functions. So we needed a new technique if we needed to take the derivative of a composite function. And recall that a composite function is one where one function goes into another. So you're putting one function into another. For example, here you're putting the function g of x into the function f, and out comes f of g of x. So, for example, the function f of x equals sine of 5x squared minus 3 is a composite. And here, the outer function, if you will, is sine of x. So that's your outer function. And your inner function, we'll call g of x, is 5x squared minus 3. So you're putting 5x squared minus 3 into the sine function, and you're getting out the answer sine of 5x squared minus 3. So how do we take the derivative of a composite function? And that's really what the chain rule is all about. It's the most important rule, so I'm going to give you a lot of practice problems. You have to master this technique, or you won't really be able to advance further with derivatives. So this is going to require a lot of practice on your part, but absolutely critical to taking derivatives. So let's try and break it into some steps. I'm going to pause here and bring in my charts. So here's the formal theorem for the chain rule, and it's written with two different versions in mind. This formal one, the first one, will help in Calc 2, and the second one I think is a little bit easier to manipulate. And then I'm going to add a third one. So let's step through it. If you have a function f and a function g, and they're both differentiable, then the composite of f with g is also differentiable, and it's defined as these two different versions. So dy dx, where y is equal to f of u, is equal to the derivative of y with respect to u times the derivative of u with respect to x. So what is that really saying? This is your inner function, g, and this is your outer function, f. So it's the derivative of the outer function times the derivative of the inner function. Well, the second version is saying the same thing. It's saying the derivative of the outer function times the derivative of the inner function, where f is defined as the outer function and g is defined as the inner function. So I'm going to give you a third kind of no-frills version of the chain rule. If you have a function, and I don't care what goes into the function, and I'm going to call it stuff, then the derivative of this function with respect to x is going to be the derivative of f, and you bring along the stuff for the ride, times the derivative of the stuff. Okay, and that goes back to here. The derivative of the outer function times the derivative of the inner function. Just keep repeating that to yourself as you're working through these problems, and you won't have any difficulty. So I wrote up, actually, I believe most of this is from the text. I think I just snipped it. Basically a how-to for version 1. We'll go through an example, and we'll see it in action, and then I'm going to do an example using version 2. But just keep in mind the derivative of the outer times the derivative of the inner, okay? Or in other words, the derivative of f of stuff, and the stuff comes along for the ride, times the derivative of the stuff. So let's look at a problem, and we'll put this into practice. I don't want to get there yet, so let's see if I can insert here. I'm having difficulty inserting a page, so we'll try and squeeze it in around this chart. Let's see how it goes. So the example, and it might be worthwhile to leave the instructions that I gave you, the how-to up there. The example that I'd like to look at is y equals the square root of x squared plus 1. So the first step in this is to identify the inner and the outer function. Let f be the outer function and g be the inner function, where u is equal to g of x. So the outer function here is actually the root function. So f of x is equal to the square root of some function, right? So that's your outer function. Your inner, this is your inner function is g of x, which we're going to let equal to u for this case, and that's equal to x squared plus 1. So that's your inner function. So let's replace g of x by u to express it in terms of u, and you get y equals the root of u. Or another way of writing that is y is equal to u to the 1/2, so that we can differentiate. So then your next step is to actually calculate this product. All right, we're gonna compute the derivative of y with respect to u, dy du, which is equal to 1/2 u to the negative 1/2. And then we're going to look at the derivative of u with respect to x. So you're going to compute each of these pieces. This is the one we just computed, now we're after this one. So what is du dx? Well, du dx, we have to take the derivative of x squared plus 1, which is simply 2x. So now you're going to multiply the two of them together. You're going to take the product of this with this, okay? So this is 1/2, I'm going to come over here, 1/2 u to the negative 1/2 times, right, du dx, which is simply 2x. So this is equal to, if I clean this up a bit, and you're left with x u to the 1/2. And the last step is to replace u with g of x. So your last step now is to replace u with g of x. So the answer here is x squared plus 1 to the 1/2. And that is your answer using the chain rule of the derivative for the function y equals the root of x squared plus 1. I'm going to pause here. So I'd like to take a minute and talk about the second version of the chain rule, which is often what we see in practice, and that is if I wanted to take the derivative of a composite function, you would take the derivative of the outer function, holding the inner constant, times the derivative of the inner function. So let's look at the example y equals cosine of 5t plus 1. This is a composite function, and your outer function, or your f of x, is equal to cosine of x. And your g of x is equal to 5t plus 1. So using this rule that I just laid out, the derivative of the outer function, well, the derivative of cosine, so I'm going to compute this right now, this piece right here. And we all know that the derivative of cosine is negative sine, and the inner just goes along for the ride. So this is 5t plus 1. So that's your first piece. Your second piece is the derivative of the inner function, and the derivative of 5t plus 1 with respect to t is simply 5. So the answer here is this times this, right? So the answer to this problem, the derivative with respect to x of y, which is a composite function, is negative 5 sine of 5t plus 1. And this is really in line with, grab another color here, with my stuff, right? This is f of stuff times the derivative of the stuff. So the derivative, pause here for a minute. Sorry about the interruption there. So using my little cheat of f of stuff. So here, f of stuff is cosine of 5t plus 1. It's a little messy there. But again, the derivative of the outside of the outside function, or the outer function, is negative sine of 5t plus 1 times the derivative of the stuff, and the stuff is inside, is 5. So this is negative 5 sine of 5t plus 1. So it's a little easier, and as you get fluid with the chain rule, you will more than likely be using, something along these two rules. So let's go back to one other last slide, and that is the chain rule for powers. And again, powers are also composite functions. So any function that looks like this, we'll do an example. Some function raised to a power is referred to as a power function. And the chain rule for powers is you're going to take the derivative, where the exponent becomes the constant multiplier, and whatever is inside, and then you take the power, you subtract 1 from the power. So you take the derivative of the outer function times, and whatever's in here, if it's some other function, right, it's going to come along for the ride, but then you need to take the derivative of the inner function. So this is the same thing. Derivative of the outer function evaluated at g of x times the derivative of the inner function. So let me pause and grab an example. Okay, so I found an example. Y equals the quantity 1 minus e to the x all raised to the 4th power. So this is a power function where the power of the outer function is 4. So take the derivative of the outside and you bring the inside along for the ride. So this is 4 1 minus e to the x to the 3rd power times the derivative of the inside. And the derivative of the inside, the derivative of 1 obviously is 0, and the derivative of negative e to the x is simply negative e to the x. So the answer to this derivative is negative 4 e to the x times the quantity 1 minus e to the x cubed. And that's the derivative of this function using the chain rule for powers. But again, it's just the chain rule. So that's it for this video. You're going to need a lot of practice with the chain rule until you can do it with your eyes closed. That's really what it's going to come down to. It's that important, and you're going to be using it constantly from here on out and through Calc 2.